This is, in turn, compounding inherent problems with the long-term growth of the chain. Even if you solve the escalating power requirements of proof of work, the data requirements of storing the chain and participating as a validator are also prohibitive in a way that inevitably centralizes power in the hands of a few wealthy operators. 85 terabytes per year is totally fine, right? Like, because 85 terabytes per year, like, if you have even one person that just keeps buying like a $100 hard drive, like I think once every month, then they can store it, right? Like, it's something like that. So it's too big for just like a casual user that just wants to run the chain on their laptop, but one dedicated user who cares, like, they can totally afford to store the chain. And so 85 terabytes is not a big deal, right? But once you crank that number higher, there comes a point at which it starts becoming a really big deal.
Now, that clip that Folding Ideas plays is from the Bankless podcast, about 40 minutes into a discussion with Vitalik. I have a question for you. Why do you think they were discussing this? Do you think Vitalik and two huge crypto fanboys on their crypto podcast were for 2 hours straight just trying to tell people about how crypto is bunk and issues like size and scalability are why? I'll give you a moment to think about whether that makes any sense. Your answer? Okay, great. Now, I'm going to go ahead and play some other parts of that same podcast, and you can decide for yourself what exactly is going on.
Now, why is that useful? One reason why that's useful is that it allows validators to be much lighter. Validators would not have to have this big, heavy database. Validators could just only verify blocks that they need to verify in real time, right? So as a validator, you would not need to have a big hard drive. You would theoretically be able to just do everything in RAM. So it will be scalable, faster, much easier to set up, much more convenient. So the experience as a validator will be much more decentralized. We want to completely move away from this idea of like users verifying things by re-executing them, right? So like Zk Snark the EVM, so that users don't even have to verify, don't have to run the EVM. Zk Snark the beacon chain transition, so that users don't have to run the beacon chain transition. Zk Snark, signature verification, so users don't have to verify signatures, right? So basically, get to the point where the only person who needs to actually run the EVM and actually like run the beacon chain like state transition function and run any of that stuff is whoever is creating a block. Everyone else just verifies one Snark, and that one Snark lets them verify the entire block. That makes it extremely easy for anyone to run a node.
And then the whole rest of the body has been Zk Snark. So it's this tiny little tail that's connected to this normal sized head. And that's how Ethereum just becomes super ultra lightweight.
Exactly. No, yes, Ethereum today is not like the layer 1 is not a system that's ready for like direct mass adoption by users. But that's exactly why we've been like harping the drum of scalability and layer 2s and sharding and all of these things pretty much since 2014, right?
Feel free to make your own conclusions. Now, this is a pretty logical place to start talking about rollups and layer 2 scaling solutions, a few of which we've already alluded to. We may as well let Vitalik start us off here as well.
So basically, rollups by themselves are a layer 2 scaling solution, and the way rollups work is that computation and storage go off-chain, but data stays on-chain, right? And this allows transactions to happen much more cheaply than they would if everything is done on layer 1, but they still inherit the security of layer 1.
At this point, you're probably getting the impression that this is a realm that involves a lot of technical jargon and requires a lot of little details to really understand. And that's true. So my goal here isn't going to be to provide a full technical breakdown of every rollup or every type of layer 2 scaling solution, and certainly not to promote any one of these as being optimal one that the whole space should adopt, but rather to provide a brief overview of what's out there and how layer 2 seeks to address many of the problems mentioned in the Folding Ideas video. There's a variety of layer 2 scaling projects out there. Bitcoin's Lightning Network, Bitcoin's Liquid Network, Parastate, Arbitrum, rollups like Optimism and ZK rollups, and Plasma with variants like Polygon Plasma. We'll go over 3 of these, state channels and Plasma, which are completely off-chain solutions, and rollups, which keep data on-chain. Let's start with state channels, as we've already mentioned Bitcoin's Lightning Network multiple times already, and we haven't really elaborated on exactly what that is. State channels, put simply, are just payment channels between two individuals that can be used for multiple payments without interacting with the underlying layer 1 blockchain for each one. Fees, for example, in the Lightning Network, are typically paid when opening the channel, which typically requires something like depositing currency into a smart contract or multi-sig wallet or some such, and when closing the channel out again, so that a miner is paid to add the final state update to the layer 1. These can be made bidirectional, such that both participants can pay each other back and forth. They have composability, such that if A has a channel open with B and B has a channel open with C, A can also interact with C. This property has implications for privacy, as you couldn't see exactly what amounts were transferred at what times to whom within the channel. Only the final ledger update once the channel is closed. And of course, since you can make multiple transactions without any mining involved, the success of Lightning or any other state channel network decreases the amount of proof of work mining required to secure the Bitcoin network, and it drastically decreases the minimum transaction amount that you could justify using the Bitcoin network for. You could indeed buy the KFC Bitcoin bucket using the Lightning Network quickly and at a reasonable cost. You just keep a state channel open with KFC and use it for multiple transactions. Now, the way I've communicated it here, it all sounds fairly simple, but the real-life implementation is actually far more complex. Now, there's actually multiple good criticisms of the concept, and I was going to try and go into a detailed discussion of them in this video, but the more I read, the more I realized it's a fairly complex subject, and I am probably going to have to make its own video for that. But we'll go into a couple of those here. For instance, how would you deal with larger payments? Would the hub and spoke model of Lightning eventually just go into a replica of basically the current model that we have right now? Since everything is done off-chain until the channel is closed, isn't the channel itself vulnerable to a host of new attack vectors? Are these new attack vectors worth introducing? Can they be shored up? Would the effect on fees and mining actually have a negative impact on the blockchain as a whole? Suffice it to say, there's a lot of potential issues, some that are bigger problems than others. More on these in a future video. Next, let's talk about Plasma, and then we'll touch on Polygon Plasma. Plasma is an Ethereum scaling solution, popularized in 2017 in a white paper by Vitalik and Joseph Poon, who himself was also one of the developers working on Bitcoin's Lightning Network. It's a layer 2 framework for what's referred to as minimum viable plasma, or MVP, that can be adapted to various different layer 1s. It started out as an Ethereum concept, but it can actually be made platform agnostic. Chains like the OMG network or Polygon adapt plasma architecture for form things like more viable plasma and Polygon plasma respectively. Plasma, like state channels, is a way of pretty much moving everything off-chain, including data and computation. Viable plasma involves the creation of child chains that are connected to their parent chains, like, say, Ethereum, through what are called root contracts. So basically, these side chains function independent of their parent chains as independent blockchains that propose commits to their parent blockchains, with new blocks being subject to a challenge period so that they can be potentially challenged and then verified with fraud proofs before they're actually committed to the parent chain. So by this mechanism, the parent chain still retains primacy over the plasma chains, with child chains offloading the computation requirements for arbitrarily many dApps while requiring pretty minimal interaction with their parent chains. This was thought to be a pretty huge boon for Ethereum scaling, given that it was entering the age of congestion and high fees. Now, Plasma has some pretty serious drawbacks. For one, its security was contingent on everybody keeping an eye out on every transaction for fraud, which actually imposes a pretty not insignificant overhead on everyone using a child chain. As well, if everyone mass exited as a response to fraud, it would just blast the parent chain with a slew of new data that it couldn't possibly handle. And for everyone that wanted to exit the child chain, you'd have to put up with a 7-day challenge period in order to do that, which sucks. Now, these days, people have generally kind of given up trying to get around these major challenges with Plasma. There was a push toward, representing coin ownership through NFTs, which was an attempt to adjust the proof requirements within the network and get around the mass exit problem. And this was called Plasma Cash. But most of these efforts have basically come to naught. And at this point, the kind of layer 2 scaling discussion in the space has moved all the way over to rollups now. We're not really thinking in terms of moving everything all the way off chain anymore. Indeed, even the aforementioned OMG network has at this point pretty much transitioned all the way to optimistic rollups, which, as we'll discuss shortly, will likely give way in the long term to ZK rollups. The project that most includes Plasma technology today is basically Polygon. It has a Plasma bridge, and this was formerly known as Matic Network. But really, that's not all they do. They actually use a combination of Plasma, optimistic rollups, ZK rollups, and then they use all of these in conjunction to reduce fees and increase scalability, with the understanding that new technologies will be incorporated as they are conceived and refined. Now let's talk about ZK rollups and the various iterations therein. First, before we really talk about ZK rollups, we have to discuss about what a Zk Snark is. A Zk Snark is a zero-knowledge, succinct, non-interactive argument of knowledge. These are basically just cryptographic proofs that allow one party to have certain information which they get to keep secret throughout the whole process, while at the same time proving that their information is valid without ever revealing any of it. Instead of revealing said information, instead, they provide a mathematical proof called a zero-knowledge proof, which can easily be verified. This technology enables things like proving your credit score is high enough for a DeFi protocol without ever actually revealing your identity or even your credit score. If that sounds like magic, it's because without a technical grasp of cryptographic mathematics, it might as well be. I won't even pretend that I can explain the details. Keep these in mind as we will run into Zk Snarks again when we get to the part about medical records. Zk rollups batch transactions using Merkle trees that are then translated into a Zk Snark that serves as a validity proof, which shows that the output of the rollup is the correct output of the computation that was moved off-chain. This proof can be verified very quickly, regardless of how much computation went into it. Rollups, whether zero-knowledge or optimistic, have a fixed cost per batch, and ZK rollups, though, have a lower per transaction on-chain gas cost. These are useful for both increasing the scalability of a chain, theoretically adding something like 570x to the TPS of Ethereum, and for, adding to the privacy of transactions. One drawback of these systems that's been criticized is that there's actually technically a requirement for a third party to set up the zero-knowledge proof system in the first place, which is a potential vector of attack. These days, there's actually an improved version of Zk Snarks called Zk Starks, zero-knowledge, scalable, transparent arguments of knowledge. These don't require a third party, but that technology, while very promising, is technically still more in an alpha stage of development. Zk Starks are supposedly also more scalable in terms of computational speed and size, as well as being actually resistant to attack by quantum computers. A more involved version of this technology is the recursive zero-knowledge proof, which is basically the key to how what's called Mina protocol works. That's another blockchain. Mina's zero-knowledge technology is recursive, meaning that they basically take zero-knowledge proofs of a batch of transactions and then batch that batch with another batch and then take a proof of that batch and so on and so forth. Basically, it's like if you prove that you had two things by taking a picture of those two things, and then you have two more things you have to, prove that you have. So you take the picture that you already had, put the two things next to that, and then you take a picture of all of those, and then you just basically keep doing that. The entire chain is compressed in this way to a total size of 22 kilobytes, and it stays at that size. An incredible feat in the modern world of crypto. Vitalik has said that something similar is in the works for the future of Ethereum, and Ethereum and Mina have actually been working together to try and, refine the technology.